So now we're going to take a look at some graphs of some exponential functions. We'll talk about some key components of exponential functions in a second, but I want to take a look at this. So I'm just going to pick a couple numbers to plug in. We're going to plug in -1 in for x. We're going to plug 0 in for x, and we're going to plug +1 in for x. Now I actually want to evaluate these, so I'm going to take this function over here, and we're going to evaluate it. So the f of -1 is 4 to the -1, and then we just talked about this in the last video. If you see something with a negative exponent, it's going to move into the denominator, so that's going to become 4 to the first power in the denominator and a 1 on top. So we have the point -1, 1/4. When I evaluate the f of 0, I get 4 to the 0 power. Remember, anything to the 0 power is 1. And then finally, when I evaluate the f of 1, I get 4 to the first power, which is 4. So let's plot these points. -1, 1/4 is right here. 0, 1 is right here. 1, 1, 2, 3, 1, 2, 3, 4 is right here. And what this is going to look like, I'm going to use a different color for this. It's going to come in from over here, it's going to cross, and it's going to head up. Okay? This is going to increase exponentially. You can see that because if I plug in 2, I'm going to get 4 squared, which is 16. 4 to the third is going to get even bigger. This increases really fast. So a couple things to note. This is always going to be on here. So we actually can come up with a couple cases here. When we plug in -1, regardless, so if I have a general function, let's just say y is equal to a to the x, where a is any number greater than 1, then we always will have the point -1, 1 over a, because it's going to flip it over. If I have When I plug 0 in, anything to the 0 power will always be 1. 0, 1 will always be on your exponential function. And then finally, when you plug in 1, you will always get the value of a, whatever a is. Again, this is only true if a is greater than 1. I want to take a second. I changed this problem. It was 1/5 to the x plus 2. I don't necessarily want to do that problem quite yet. I want to work on this one right here. We can see there's a couple shifts of graphs. We know a +2 on the inside of the function should move it left 2. So when I transform, I'm going to take my x value and I'm going to subtract 2. And then the 3 on the outside, that is a vertical stretch by a factor of 3. I know it's been a while, but when we do this stretch, we're going to take our y values and multiply them by 3. Notice, what is the base of this function? This is 5 raised to the exponent, right? So our base function is going to be y is equal to 5 to the x. And remember, couple key points we just talked about. So when I plug -1 in, we're always going to have the point 1/5. When I plug 0 is always going to be 1. And finally, when I plug 1 in, I'm also going to get 5. Now we're going to transform these. We're going to shift it left 2, so we're going to move those y values to the left 2. So it's now going to be -3, -2, and -1, because we moved all of these points to the left 2 places. And we're going to vertically stretch those y values by a factor of 3. So this is going to be 3/5. This is going to be 1 times 3 is 3, and 5 times 3 is 15. So we'll plot those points. So -3, 3/5 is right here. -2, 3 is right here. And then -115 isn't even on this graph. I don't think it's somewhere up here. So you can see what it did was it took that exponential and it moved it to the left, and then it stretched it out because it's increasing at an even faster angle.